Hello students, in this video we are going to discuss chemical reactions of aldehydes and ketones due to acidic nature of alpha hydrogen. So in this session we are going to discuss chemical reactions of aldehydes and ketones, that is chemical reaction due to alpha hydrogen. Now these alpha hydrogen atoms present in what? In an aldehyde or in a ketone, it is found to be acidic. Alpha hydrogen atoms of carbonyl compounds. Alpha hydrogen atoms of carbonyl compounds. Carbonyl compounds means aldehydes or ketones. These alpha hydrogen atoms are acidic. Alpha hydrogen atoms are acidic. See, because of this acidic nature of alpha hydrogen, aldehydes and ketones undergo number of chemical reactions. I will repeat it once again. Aldehydes and ketones or carbonyl compounds undergo number of chemical reactions due to acidic nature of alpha hydrogen. Due to what? Due to acidic nature of alpha hydrogen. Now what are these alpha hydrogen atoms? Carbonyl compound means there should be C double bond O group, that is carbonyl group. This is aldehyde or ketone. And this carbonyl group, it is the functional group of aldehydes and ketones. Aldehydes and ketones, C double bond O. Now nearer to this functional group, there will be a carbon atom. There will be what? There will be a carbon atom. This carbon, it is named as alpha carbon. So a carbon atom which is very next to the functional group. Carbon atom which is very next to the functional group. That carbon, it is called as what? Alpha carbon. If there is one more carbon, then it is named as beta, then gamma, delta, etc. So this carbon, it is alpha. So carbon atom which is very next to the functional group, that carbon atom, it is named as alpha carbon atom. Then what do you mean by alpha hydrogen? Hydrogen atom present upon alpha carbon, or hydrogen atoms found in a carbon. So hydrogen atom which are directly attached to alpha carbon atom, those hydrogen atoms are considered as what? Alpha hydrogen atoms. Alpha hydrogen atoms. So alpha hydrogen atom is hydrogen atom which is directly bonded to alpha carbon. Directly bonded to alpha carbon. Now these alpha hydrogen atoms of aldehydes and ketones, they are found to be acidic. They are found to be what? Acidic. What do you mean by acidic nature? Acidic means hydrogen which can be removed in the form of H plus. In the form of what? H plus. So any substance, if it produces H plus ion, then it is called as an acid. Correct? It is called as an acid. So here alpha hydrogen atoms are acidic, means these hydrogen, this is alpha hydrogen, and this hydrogen, what is this? Alpha hydrogen, it is acidic. It is what? It is acidic, means this hydrogen can be easily removed. This hydrogen can be what? Can be easily removed in the form of H plus. So it can be easily removed means what? This bond must be weaker. Carbon hydrogen bond must be weaker. Since this bond, it is weaker, a base, what is the role of a base? Acid always donates H plus. Base always accepts H plus. So any base we can take. So if we consider any base, this base will readily take up, or it will readily abstract this proton. It will take up this proton. So base readily accepts proton because this bond, it is weaker. Carbon hydrogen bond, it is weaker. Hydrogen, it can be easily removed in the form of H plus. Now why this bond, carbon hydrogen bond, it is found to be weaker? Why it is weaker in nature, this bond, carbon hydrogen bond? This is due to the presence of carbonyl group. Due to what? Due to the presence of carbonyl group. And this carbonyl group, it is found to be electron withdrawing in nature, or it is an electron withdrawing group. Carbonyl group, it is what? It is electron withdrawing group. And this electron withdrawing group, that is carbonyl group, it will readily attract electrons towards itself. So electrons will move in this direction. So movement of electrons, it is like this. This is sp3 carbon. What about this one? This carbon, it is sp2 hybridized carbon. sp2 hybridized carbon, it is more electronegative compared to sp3. So this sp2 carbon readily attracts electrons from what? From sp3 carbon. From what? From sp3 carbon. As a result, sp3 carbon becomes electron deficient. Once it becomes electron deficient, this carbon readily attracts electrons of what? Attracts electrons of carbon hydrogen bond. As a result, carbon hydrogen bond becomes weaker. So carbon hydrogen bond, it is found to be weaker. It is due to electron withdrawing nature of carbonyl group. So oxygen, we know that it is highly electronegative. It readily withdraws electrons from the carbon, and this carbon being sp2 hybridized, it will attract the electrons from sp3, and this sp3 carbon attracts the electrons of carbon hydrogen bond. As a result, carbon hydrogen bond becomes weaker, removal of hydrogen becomes easier. So we can write the reaction here, that is abstraction of proton. See, this is hydrogen. This hydrogen, it is readily accepted by what? By a base. Once it accepts this electron, electrons shared pair of electrons will be shifted to carbon, correct? So as a result, we'll get what? We'll get C. This is C double bond O. Here I would write minus charge. Here I would write minus charge. So this is the ion obtained after the abstraction of proton. After the abstraction of proton, and this ion will undergo resonance like this. It will undergo resonance, giving what? Giving C double bond C single bond O minus. So anion formed, it is stabilized by what? Stabilized by resonance. So for 1 mark they can ask, alpha hydrogen atoms of carbonyl compounds are acidic, give reason. So what is the answer? Alpha hydrogen atoms are acidic. It is mainly due to electron withdrawing nature of carbonyl group. Electron withdrawing nature of carbonyl. So because of electron withdrawing nature of carbonyl group, electron directly moves into what? Moves towards oxygen. As a result, carbon hydrogen bond becomes weaker, removal of hydrogen becomes easier. So first reason, it is due to electron withdrawing nature of carbonyl group. That is the first reason. Second reason, the anion formed after the abstraction of proton, this anion, it is stabilized by resonance, or resonance stabilization of conjugate base is this is conjugate base. This compound, it is an acid because it donates H plus. So once we remove H plus, formed product we call it as conjugate base. So this is conjugate base. Conjugate base, it is obtained by removal of proton. So conjugate base, it is stabilized by resonance. First one, electron withdrawing nature of carbonyl group. Second one, resonance stabilization of conjugate base. Resonance stabilization of conjugate base. Now we can take up the reaction of aldehydes and ketones due to acidic nature of alpha hydrogen. Acidic nature of what? Alpha hydrogen. First reaction, very important reaction. That reaction, it is called Aldol condensation. Aldol condensation, it is also called as self condensation. Aldol condensation, or it is self condensation. See, aldol condensation, it is answered only by those aldehydes and ketones. It is answered only by those aldehydes and ketones which contain alpha hydrogen, So without having alpha hydrogen, carbonyl compounds cannot undergo aldol condensation or aldol reaction. So only aldehydes and ketones containing alpha hydrogen, containing alpha hydrogen undergo this reaction. So aldol condensation, it is seen only in those aldehydes and ketones which possess alpha hydrogen, Now if I take formaldehyde, formula of formaldehyde, it is like this. It is HC double bond OH. This is formaldehyde. See, formaldehyde does not undergo aldol condensation. Why? Because in formaldehyde, see, this is functional group. Nearer to the functional group, we can't see any carbon. So there should be one carbon. That carbon we name it as alpha carbon, and hydrogen present in that alpha carbon we name it as alpha hydrogen. But here, in the case of formaldehyde, there are hydrogen atoms, but they are not present upon alpha carbon atom. So these hydrogens, they are not considered as alpha hydrogen. So formaldehyde does not contain any alpha hydrogen, so it does not undergo aldol condensation. One more, benzaldehyde, benzene ring containing aldehyde group. This is benzaldehyde. Benzaldehyde does not undergo aldol condensation. Just like formaldehyde, benzaldehyde does not undergo aldol condensation. Why? Again, in benzaldehyde, there is no alpha hydrogen. See, this is the functional group present in this molecule, benzaldehyde. Nearer to this functional group, there is one carbon. This carbon we name it as alpha carbon, but this alpha carbon does not contain any hydrogen. Here we can see hydrogen atoms in these positions, but this position does not contain any hydrogen. So benzaldehyde does not contain any alpha hydrogen, so it cannot undergo aldol condensation. So formaldehyde and benzaldehyde does not show aldol condensation because of the absence of alpha hydrogen. Aldol condensation, it is seen only when aldehydes and ketones possess alpha hydrogen. Now let us explain this reaction, aldol condensation. In aldol condensation or in self condensation, aldehydes or ketones containing alpha hydrogen, this one, aldehydes and ketones containing alpha hydrogen, they are heated with, these compounds are heated with dilute solution of a base. That is dilute sodium hydroxide. Reaction takes place forming beta hydroxyaldehyde. It is called as aldol, beta hydroxyaldehyde or beta hydroxyketone. It is also called as ketol. So aldehydes or ketones containing alpha hydrogen, when heated in the presence of dilute sodium hydroxide is the catalyst. So in the presence of dilute sodium hydroxide, reaction occurs forming what? Forming beta hydroxyaldehyde. It is named as aldol, or beta hydroxy ketone named as what? Ketol. So aldol, it is the product obtained when aldehyde reacts with dilute NaOH. Ketol, it is the product formed when ketone reacts with dilute NaOH. Now we can write the equation. I will take acetaldehyde, or it is ethanol. See, this is ethanol. Ethanol means Al means aldehyde. Eth means 2 carbon atoms. This is ethanol. I have to take 2 molecules. Self reaction, it is taking place between same 2 molecules. Same 2 molecules. So it is called as self condensation. Write one more molecule. I'll write that second molecule like this. I'll take up H, then CH2, C double bond O, single bond H. Write it in reverse manner. CH3 can be written like this. Now this is alpha carbon, and this hydrogen, it is alpha hydrogen. Because of this alpha hydrogen, reaction takes place. Reaction, it is seen due to the presence of what? Alpha hydrogen. So this is alpha carbon atom. This hydrogen, it is named as alpha hydrogen. So you have to show that alpha hydrogen. Correct. Now here in this carbonyl group, carbon carries positive charge, oxygen carries negative charge. That we know. In carbonyl compounds, carbonyl group, it is polarized. Carbon carries partial positive charge, oxygen carries partial negative charge. Now what about here? This is alpha hydrogen. Alpha hydrogen atoms are acidic. Alpha hydrogen atoms are acidic, means what? This is positively charged. This is what? Positively charged. Then what about carbon? Alpha carbon. It is negatively charged. It is what? Negatively charged. Now add these two. See, this nucleophile will attack here, positive center. This is negatively charged, will attack the positive center. Electrons will be completely shifted to oxygen. H plus will be added. Reaction, it is a reversible reaction. Catalyst we have to mention here, that is dilute NaOH. Dilute NaOH. So H, it is added to oxygen. This one, that is CH2 CHO. CH2 CHO. It is added to carbon. So product formed will be CH3, first one. Then it is CH. I will write it together. CH. After the addition, double bond becomes what? It becomes single bond. Single bond OH. Correct. Then I have to write this one. CH2 C double bond O. It is H. CH2 C double bond O H. This product, it is called beta hydroxyaldehyde. See, we can see two functional groups here. One is alcohol, other one is aldehyde. Preference goes to aldehyde. So this is the principal functional group. This is taken as the substituent group. Carbon which is nearer to the functional group. This is alpha carbon. This is beta carbon. Beta carbon. So it is beta hydroxy. Beta hydroxyaldehyde. Beta hydroxyaldehyde, also called as what? Also called as aldol. Also called as what? Aldol. Why it is named as aldol? Why this product it is named as aldol? This product it is named as aldol because formed product contains both aldehyde group as well as alcoholic group. So in this product we can see what? We can see aldehyde group. This is aldehyde group. OH means what? OH means alcoholic group. So formed product, since it contains both aldehyde group as well as alcoholic group, product it is named as what? Product it is named as aldol. Product it is named as what? Aldol. In the next step, this aldol upon heating, upon what? Upon heating loses water molecule. Loses what? Water molecule. So for the removal of water, we need what? We need H and OH. We need what? H and OH. OH we can see here. There is the OH group. That is upon beta carbon, remove hydrogen from alpha carbon, not from gamma. Remove hydrogen from alpha carbon because removal of hydrogen it is easier. Removal of hydrogen from the alpha carbon atom it is easier because those hydrogen atoms are acidic. They are what? They are acidic. So I will remove one of the hydrogen. I will write that hydrogen above like this. So water molecule will be removed upon heating. Removal of water takes place forming CH3, then it is CH. See, due to the loss of hydrogen and OH group, there exists a double bond, that is CH double bond CH, C double bond O, single bond H, single bond H. Now this product it is named as what? This is the functional group, this is alpha, this is beta. So compound it is named as alpha comma beta, alpha comma beta. So between these two alpha and beta carbon atom there is a double bond. So what I can write? It is unsaturated, alpha comma beta unsaturated carbonyl compound, alpha comma beta unsaturated carbonyl compound, or IUP is the name. Functional group should get the least number, carbon number 1, second one, third one, fourth one, correct. So total number of carbon atom it is 4, so it is but. We can't write ANE because there is a double bond. At second position it is 2 in, that is En, 1 Al. Al represents aldehyde group. So but 2 in 1 al, or it is alpha comma beta unsaturated carbonyl compound, unsaturated carbonyl compound. We can take one more example, acetone. It is also called as propanone. Okay. CH3, C double bond O, CH3. Write one more molecule, that is H, CH2, C double bond O, CH3, C double bond O, CH3. Let us write the polarities. So carbon carries positive charge, oxygen carries negative charge. That is in first molecule. In the second molecule, see this is acidic, alpha hydrogen it is acidic. This carbon carries negative charge. So let us add these two groups. It is added to carbon. Hope there is no doubt in this. Double arrow, we can write dilute NaOH or even barium hydroxide. This is also an example for base only. Barium hydroxide also we can take. I will write the product CH3, C to the oxygen atom hydrogen it is added, single bond OH. I will write this CH3 here. Okay. Write this group CH2, C double bond O, CH3, C double bond O, CH3. This is ketol because product it is obtained due to the reaction of what? Two molecules of ketone. It is ketol, and this ketol readily loses water. This is ketol, or it is beta hydroxy. This is alpha, this is beta, because this is the functional group. Beta hydroxy ketone. Beta hydroxy ketone. Now this beta hydroxy ketone, when heated, loses water. Loses water. Remove hydrogen from the alpha carbon. So formed product will be CH3, CH3. There exists a double bond due to the loss of hydrogen and OH group. Again it is CH, C double bond O, CH3, C double bond O, CH3. We can name this compound. This is carbon number 1, second one, third one, fourth one, fifth one. Fourth carbon atom contains one substituent group, that is 4 methyl. 4 methyl. So prefix over, write the root word. Total number of carbon atom, it is 5. It is pent. Pent. There is a double bond. 3En, 2 ONE. 4 methyl pent 3En 2 ONE. That is the final product, or this is alpha comma beta. This is alpha, this is beta. Between these two carbon, alpha and beta carbon, there is a double bond, or there is a unsaturation. So this is alpha comma beta unsaturated carbonyl compound, or it is specifically 4 methyl pent 3En 2 ONE. Pent 3En 2 ONE. In the exam, question will be asked like this: what happens when ethanol? What happens when ethanol is heated with dilute solution of NaOH? Write the equation. What happens when ethanol? Ethanol means acetaldehyde. Acetaldehyde heated with dilute solution of NaOH. Write the equation. Dilute solution. If they ask dilute solution, immediately you have to remember that is, as the reaction, it is what? It is Aldol condensation or self condensation. Next, second reaction, that is reaction due to alpha hydrogen. That reaction, it is named as cross Aldol reaction. Cross Aldol reaction. Cross Aldol reaction means Aldol reaction taking place between two different aldehydes. Aldol reaction taking place between two different aldehydes, two different ketones, or an aldehyde and a ketone. So either it should be two different aldehydes, or it can be two different ketones, or an aldehyde and a ketone. So suppose Aldol reaction, if it takes place between these, that is between two different aldehydes, two different ketones, or aldehyde and ketone, then that Aldol condensation, it is named as cross Aldol condensation. Named as what? Cross Aldol condensation. Let us take up one example for this cross Aldol condensation. I will take benzaldehyde. This is benzaldehyde. Benzaldehyde. This benzaldehyde does not contain any alpha hydrogen. There is no alpha hydrogen in benzaldehyde. One more compound we have to take. Other one I will take aromatic ketone. This is aromatic ketone. Name of this ketone is acetophenone. Name of this ketone, it is what? It is acetophenone, and this acetophenone contains alpha carbon and alpha hydrogen. Alpha carbon and alpha hydrogen. So compound which contains alpha hydrogen, we have to write it in the second position. Compound which does not contain any alpha hydrogen, we can write it in the beginning. Okay. So benzaldehyde does not contain any alpha hydrogen, so I wrote it in the beginning itself. Acetophenone contains alpha hydrogen, so I wrote it in the second position. Now I can add acetophenone to benzaldehyde. In benzaldehyde, carbonyl carbon carries positive charge, oxygen carries what? Negative charge. Here alpha hydrogen, it is negatively charged, carbon it is what? Sorry, hydrogen it is positively charged, carbon it is negatively charged. So this hydrogen, it is added across oxygen. This group, whole group, it is added to carbon. Reaction, it takes place in the presence of what? In the presence of dilute sodium hydroxide. dilute sodium hydroxide. So product formed, it is benzene ring, then it is CH. I will write this carbon hydrogen bond together, CH, single bond OH, single bond OH, remaining group, that is CH2, C double bond O, again benzene ring. Now this compound readily loses what? Readily loses water upon heating. Upon what? Upon heating. So this is alpha carbon. So it will lose one hydrogen. Removal of water, benzene ring or aromatic ring. Then it is CH, double bond CH, C double bond O, again benzene ring. Okay, this is the final product. We can name this product. This is the parent chain because this parent chain contains what? Contains functional group. These two aromatic ring, they are considered as what? Substituent groups. Considered as what? Substituent groups. Name of this substituent group, it is phenyl. This is also phenyl. Let us name this compound 1, 2, 3. It is 1,3 diphenyl. 1,3 diphenyl. This is phenyl, this is also phenyl. Phenyl groups are present at carbon number 1 and carbon number 3. So it is 1,3 diphenyl. Root word prop. It is what? Prop 2 in 1 ONE. 1 ONE. Prop 2 in 1 ONE. It is also called as, commonly it is called as benzyl estophenone. This compound, it is also named as what? Benzyl estophenone, because this compound, it is obtained by the reaction of benzaldehyde and estophenone. Benzaldehyde and estophenone. So it is also called as benzyl estophenone, or it is 1,3 diphenyl prop 2 in 1 ONE. 2 in 1 ONE. So this is about cross Aldol condensation or cross Aldol reaction. Suppose if I take, say in this example, one of the compound contains alpha hydrogen, other one does not contain any alpha hydrogen. So if I take ethanol, that is CH3CHO, and propanol, CH3 CH2CHO. If I take this example, now these two are aldehydes, two different aldehydes. So this is also an example for cross Aldol condensation. Now ethanol contains alpha hydrogen, propanol also contains alpha hydrogen. So if both the compounds contain alpha hydrogen, then 4 different products are formed. 4 different products are formed. How they are formed? See, ethanol can be added to ethanol. So because of this, we'll get one product. Propanol can be added to propanol. Propanol plus propanol. Okay. So these products are called self-condensation products, or it is self-aldol product. What is this? Self-aldol product. What about other two? So first two I wrote, ethanol plus ethanol. Second one, propanol plus propanol. What about third one and fourth one? Ethanol can be added to propanol. Because of this, we will get one product. Or propanol plus ethanol. This possibility is also there. These products are called, these are what? These are cross Aldol products. So if the taken compounds, if both the compounds contain alpha hydrogen, then we can get 4 different products. Suppose if I take ethanol and propanol, a reaction can take place between ethanol and ethanol. Because of that, we will get one product. Propanol and propanol can react. Again, second product, propanol can be added to ethanol, that is the third product. Ethanol can be added to propanol, that is fourth product. So out of four, two of them are self-aldol products because both aldehydes are same. So it is self-aldol product. These two aldehydes are different. So these two are cross-aldol products. You can try this. You can write the equation for this. It is reaction taking place between ethanol and propanol. Next one, Cannizzaro's reaction. Cannizzaro's reaction, very important, just like Aldol reaction. This is Cannizzaro's reaction. It is an example for what? Disproportionation reaction. Disproportionation reaction. What is disproportionation? Disproportionation, it is a redox reaction. It is what? It is a redox reaction where same species simultaneously undergoing oxidation as well as reduction. Same species undergoing oxidation as well as reduction. Such a reaction we call it as disproportionation reaction. So Cannizzaro's reaction, it is an example for disproportionation reaction. See, Cannizzaro's reaction, it is answered only by those aldehydes which does not contain any alpha hydrogen. Which does not contain any alpha hydrogen. So Cannizzaro's reaction, it is seen in only two compounds. One is formaldehyde, other one is benzaldehyde. Cannizzaro's reaction, it is answered only by two compounds, formaldehyde and benzaldehyde. Formaldehyde does not contain any hydrogen. Benzaldehyde also does not possess any alpha hydrogen. So because of the absence of alpha hydrogen, these two compounds readily undergo Cannizzaro's reaction. Readily undergo what? Cannizzaro's reaction. So Cannizzaro's reaction, it is seen in those aldehydes which does not contain alpha hydrogen. Does not contain alpha hydrogen. Now what is Cannizzaro's reaction? In Cannizzaro's reaction, aldehydes which do not contain alpha hydrogen, it is heated. Those aldehydes are heated. That is either formaldehyde or benzaldehyde. It is heated in the presence of concentrated solution of a base. That is either concentrated sodium hydroxide or concentrated solution of potassium hydroxide. Either formaldehyde or benzaldehyde, it is heated with what? Concentrated solution of sodium hydroxide or concentrated solution of potassium hydroxide. So when we heat formaldehyde or benzaldehyde with concentrated solution of a base, that formaldehyde will simultaneously undergoes oxidation as well as reduction. So we have to take two molecules. Out of those two molecules, one molecule of formaldehyde undergoes oxidation, other molecule of aldehyde undergoes reduction. So it is considered as disproportionation reaction. It is considered as what? Disproportionation reaction. I will write the equation. This is HCHO, formaldehyde, or I can write the structure like this. It is H, C double bond OH. This is the first molecule. I will take one more. H, C double bond OH, heated with concentrated sodium hydroxide. Heated with what? Heated with concentrated solution of sodium hydroxide. This is formaldehyde. Both the molecules are formaldehyde. Now out of these two molecules, one of the molecule undergoes oxidation, other molecule undergoes reduction. One molecule undergoes oxidation, other molecule undergoes what? reduction. Now in the last class we studied oxidation of an aldehyde produces carboxylic acid. Produces what? Carboxylic acid. So this is HCHO. Formaldehyde means HCHO. This will undergo oxidation forming carboxylic acid, that is formic acid. That is what? Formic acid. So oxidation of formaldehyde gives formic acid. This compound is acidic. Compound is what? Acidic. Since this compound is acidic, it will readily react with the base, that is sodium hydroxide. Reaction it is carried out in basic medium. So formed product readily reacts with the base. Readily reacts with the base forming a salt. So this formic acid reacts with sodium hydroxide forming sodium salt. What is that sodium salt? It is HCOONA along with water. Along with water. So oxidation of formaldehyde gives sodium salt of formic acid HCOONA. This is sodium formate. Sodium formate. Now second molecule, it is undergoing reduction. What is reduction? Reduction means addition of hydrogen. Add hydrogen across carbon oxygen double bond here. So one hydrogen is added here, other hydrogen it is added to carbon. So product formed will be, it is H, CH, single bond OH, single bond H, or it is CH3OH, CH3OH, CH3OH. So formaldehyde heated with concentrated sodium hydroxide gives sodium salt of formic acid along with primary alcohol. Along with primary alcohol. So oxidation of aldehyde gives carboxylic acid. Reduction of aldehyde gives primary alcohol. Second example we can take. Benzaldehyde. These molecules are named as benzaldehyde. Two molecules of benzaldehyde heated with, I will take KOH, concentrated KOH, heated delta. See this aldehyde, it will undergo oxidation forming benzoic acid. C6H5CHO becomes what? C6H5COOH. COOH, benzoic acid, it will react with the base which is present in the medium forming C6H5COONA. COONA. So product formed, it is C6H5COONA. Now this is the product obtained due to oxidation of benzaldehyde. Let us write one more product, that is due to reduction of benzaldehyde. Add hydrogen atoms here across carbon oxygen double bond. So it is C6H5CHOH, it is H, or it is C6H5CH2OH, CH2OH. C6H5CH2 group, it is called as benzyl group. This group it is called as what? Benzyl alcohol. Benzyl alcohol, and this sodium salt, it is named as sodium benzoate. Sodium salt of benzoic acid, it is named as what? Sodium benzoate. This is the product obtained due to oxidation, and this is the product obtained due to what? Due to reduction, that is benzyl alcohol. Benzyl means C6H5CH2. C6H5CH2 group it is called as benzyl. OH means alcohol. So product it is named as benzyl alcohol. So this is about Cannizzaro's reaction. Even for 1 mark they can ask, HCHO undergoes Cannizzaro's reaction. Give reason. Why? What is the reason? Because HCHO does not possess any alpha hydrogen, or C6H5CHO undergoes Cannizzaro's reaction because benzaldehyde C6H5CHO does not contain any alpha hydrogen, so it readily undergoes Cannizzaro's reaction. Don't write any other examples. You have to take either formaldehyde or benzaldehyde for Cannizzaro's reaction. Only these two aldehydes, they are undergoing Cannizzaro's reaction, whereas remaining aldehydes and ketones contain alpha hydrogen. Last reaction, electrophilic substitution. Electrophilic substitution of benzaldehyde. Electrophilic substitution reactions of benzaldehyde. Here we have to study only one reaction, that is nitration of benzaldehyde. Now what do you mean by electrophilic substitution for an aromatic ring? Electrophilic substitution means replacing hydrogen atom of the benzene ring. Replacing hydrogen atom of the benzene ring by an electrophile. By what? By an electrophile. So in an aromatic ring, if I replace hydrogen atom by an electrophile, then that reaction, it is named as what? Electrophilic substitution. Now benzaldehyde, structure of benzaldehyde, it is like this. Say this is benzaldehyde. In benzaldehyde, there is resonance. There is what? There is resonance. This type of resonance, it is called as minus R effect. What is this? Minus R effect. So aldehyde group, this is aldehyde group, being an electron withdrawing group. Being what? Being an electron withdrawing group. It readily attracts electrons from the benzene ring. It won't donate any electrons to the benzene ring. So suppose if it is donating electrons to the benzene ring, then benzene ring becomes electron rich. Where? At ortho position and para position. But this aldehyde group will attract the electrons from the benzene ring like this. This resonance we call it as minus R effect. Minus R effect. So since electrons are shifted from the aromatic ring to this group, electron withdrawing group, positive charge will be created here. So in the next resonance structure, this electron will be shifted. So positive charge will be created here. Again, this electron will shift here. Again, positive charge is created. So suppose if an aromatic ring, if it contains electron withdrawing group, then during resonance, ortho and para positions carry positive charge. What about electron donating group? You studied phenol. See in phenol, there is OH group. In OH, oxygen contains lone pair of electron, and this group we call it as electron donating group. It readily donates its electron to the benzene ring. So negative charge is created here, ortho position. Again in the next resonance structure, once again negative charge at para position. In the third resonance structure, again negative charge. So if there is electron donating group, then ortho para positions will be electron rich. If an aromatic ring, if it contains electron withdrawing group, then due to the abstraction of electrons from the ring becomes electron deficient. Aromatic ring becomes electron deficient at ortho and para position. So upon electrophilic substitution, electrophile prefers to attack meta position. This is meta. It prefers to attack where? Meta position, because meta position it is somewhat rich. Electron rich, whereas ortho and para it is electron deficient. So electron deficient species can't attack electron deficient center only. It always attacks electron rich center. In a benzaldehyde molecule, meta position it is somewhat electron rich compared to ortho and para position. So upon electrophilic substitution, we'll get a meta product. Let us write the equation. Nitration. Benzaldehyde. This is benzaldehyde. This benzaldehyde, it is subjected to nitration. For nitration we need concentrated nitric acid along with concentrated sulfuric acid. This mixture we call it as nitrating mixture. Nitrating mixture. So benzaldehyde subjected to nitration by adding concentrated nitric acid along with concentrated sulfuric acid at a temperature of 273 to 283 Kelvin, 0 degree to 10 degree Celsius. 0 degree to 10 degree Celsius, nitration occurs. What is nitration? Replacing hydrogen by nitro group. Replacing hydrogen by nitro group. So here NO2 plus, it is the electrophile in nitration. So benzaldehyde, this electrophile, it prefers to attack meta. This is meta. 1, 2, 3. 1, 3 position, it is named as meta position. Whereas 1, 2 it is ortho, 1, 4 it is para. Benzaldehyde undergoes nitration in the presence of nitric acid and sulfuric acid at a very low temperature, that is 0 degree to 10 degree Celsius, forming meta-nitro benzaldehyde. Meta-nitro benzaldehyde. Okay, this is nitration of benzaldehyde. So nitration of benzaldehyde produces meta product, that is meta-nitro benzaldehyde. This completes aldehydes and ketones. Next we are moving on to carboxylic acids. Thank you.